Bye-bye.
Hello, Mr. Violet, right? Yes?
Sort of.
Okay. So we're given a binary string with 0 and 1. All ones, okay? Binary strings.
Ooh.
Like that.
That's odd, that's even.
Good job, but this is not it. Okay, so we want to find out the consecutive ones, the number of the maximum consecutive ones, and the number of maximum consecutive zeros. So we want to return true if the number of consecutive ones, the maximum is more than the number of the maximum consecutive zeros.
But what if they're equal?
That's true. So
And it's wrong.
it's wrong, yes. So for example here, yeah, you're right, yeah. There are two. The maximum consecutive one is 2, right? And the maximum consecutive 0 is 1. So 2 bigger than 1, true. This one is 3 is not equal than 3, okay? It's not bigger than 3. And here it's 1 and 1. 1 is not bigger than 1, so wrong, okay?
So the amount of ones greater than the zeros or zeros greater than the ones? Which one? The ones greater than zeros or the zeros are greater than ones?
Yeah, we want to return if the number of ones, the consecutive one, the maximum one, right, is bigger than the consecutive 0, the maximum consecutive 0. Okay, so if there's no zeros, then the consecutive 0 is 0. Okay, if there is no 1 in the binary string, then we can think of it as 0. The length of the maximum consecutive ones is 0. Okay, does it make sense? What's in your mind, this question?
So we go through it twice because might not be the quickest way, but you just go through it once, checking the ones, and then
Go through it again, checking those zeros.
yeah.
That's good, but can we just go through it once?
Yes, you use a set and then count. And count the ones
Oh, okay.
first. If count the ones first, and if there's a count and if there's a 0 after that, then you stop and remember how much
Okay.
ones, and then you start counting the zeros.
Well done, okay? That's
And
true.
then if the stop 0, you start count. You remember it and start counting the ones again.
Okay. This example, how do we find out? Okay, so I'm
I
here
already
1.
said it.
Can you say it with the example? Okay, so now this is 1.
You start counting the ones.
Yeah.
So and then there's 2 ones and you put it.
Actually,
But now the next one is 0. So you put it number 2 in the set. So
Maybe
there's
you
2 ones, and then you start counting 0. But then that's 1 0. But then after that is another one. So you remember how much 0, which is 1,
wait,
and then go to 1, count 1, and there's 1, and since you end, and 2 is greater than 1 in the set, so it's true.
Okay, so we can actually go through each bit of the binary string, and then we check, right? Look, we just need the 4 variables. Actually, need the 4 variables. What are those? Max ones, consecutive ones. Max consecutive 0. Okay? And then current ones. And current zeros. Okay? Does it make sense? Okay, let's take a look at these 4 variables. Okay? Now this is 1. Once we meet the 1, we should set the current ones plus 1. So now it's 0, right? We need to plus 1. And then if we meet the 1, so we need to set this to 0, am I right? Because now this is 1, so the zeros should be set to 0, right? Okay, and then the max 1 is 1 so far. Max 0 is 0. Okay? Now 1 plus 1. We have meet another 1. So we need to plus 1 here. Now current 1 is 2. We set it to 0. And then current max 1 we have seen so far is 2. The max 0 is 0, 0. Okay, now 1. And now we move into 0. Sit down. Moving to 0. So what happened? The current ones, I should set it to 0 because now it's 0, right? So the 1 should be 0. And then the 0 should be plus 1. The max 1 is still 2. The max 0 is 1. Okay? It's 1. And then again, here, 1, we have 1. So we plus 1. Here, we set it to 0. And the max 1 is 2. Because max 1 is 2. We have only 1. So it's less than 2. Max 0 doesn't change. Okay. To put it in simple words, when we meet the 1, we increment the current ones, and at the meantime we reset the zeros to 0. Okay, and then we keep tracking of these two maximum, and then at the end we just return if the max one is bigger than max 0. Okay, make sense?
Yeah.
Simple. That's one scan, right? Just perform one scan. Okay, now
What if there's like 1 million? Lots of numbers then.
we still have to go through, right? Because this is the only way to find out. Am I right?
Is it the only way?
We need to go through each number to count, to find out, right? There's no way to just abandon, just to check maybe half of it to find out the answer. We have to go through, we have to check. This is common sense, right? Let me write the code, okay? Define f. Okay, max 1 equals 0.
Yeah,
Max
you
0 equals 0.
always been like sitting down.
Current 0 is 0. Current 1 is 0. Okay? So these four variables. And you tell me, come on please. For I in S, if I equal
Also,
1.
also, you've been like sitting for like most lessons, and then now you just think, oh, this is more comfortable.
Okay? If we have meet 1, so what do we do here? Else, then what do we do here? And then here is max 1 equals the max of max 1 what? Max 0 equals max 0 what? And then return what bigger than what, okay?
Max 1 equals max 1 max.
I can do it.
Max.
You can do all of it.
Max
Yeah.
1 equals
No,
max,
that's it.
max 1, max 0.
Which one? Max 1 equals max
The
1?
first one, max 0.
Which-
No, I mean here. Is it max 0?
No, why is max 0? So max 1 is the current ones we have, the maximum ones we have seen. So max 1 equals max 1. Which variable is the one, the number of ones, current ones?
Current one.
We're down, current 1. Okay, and here?
Current.
0.
We're down, okay? And then here?
Max 1 greater than
At
max
this
0.
point,
Okay, okay. And then here, these four. If I is 1, we have meet 1, so
If I equals 1,
So-
max one.
Insert-
Plus one.
insert
current 1
you
plus equal 1. And then here, what do we?
Yay!
What's this here? We have meet 1, so what happened to
you
0?
go to the right.
Current 0 is go back. Smiley face.
Current 0 equals 0.
Zero.
Okay, and then here, if we have meet 0, what do we do here? This is the opposite of here.
Current one. Subtract one.
Why is it subtract?
Because you said it's the opposite thing, Barry.
If we have meet 0 here, so which variable should increment 1? Current
Equals 0.
0. We have
Plus
meet
one. Plus one.
plus equal, and then here,
Current one equals 0.
yeah, because okay.
So opposite.
Does it make sense? Does it make sense?
So opposite.
Okay. So this is the one, right?
If
Okay.
it was opposite, then it would be current 1 subtract 1 and current 0 equals current 0.
Is this a easy question? Yeah. Okay. So this is the basic, right? This is the how we solve this problem in this basic way, in a pure algorithm way. Going through from left to right, checking each bit. If it's 1, we increment the current 1 and reset current 0. If it's 0, we increment the current 0 and reset current 1. Okay, and then at each iteration, we just keep tracking of the current, the maximum 1 or maximum 0 we have seen so far, and then the answer is maximum figure in x. We can use another function. Let's look at the ones for now. What's this 0 here? It's like a separator, right? Delimiter, right? So we can use the functions to group by. What's that function? What's the opposite of join? What's that function?
Split.
Yeah, we can split by 0, right? So look here, if we split by 0, so let's say now ones equals s dot split by 0, right? And then the zeros equals s dot split 1, right? Once we split it, we have an array of ones. So ones will be, if we split by 0, it will be like that, right? 1, 1, and 1, am I right? Okay, this is 1. Then we can find out the length, the maximum. And similarly, we can do this for the zeros. The number of 1, the max 1, right? We want to find out the maximum of length I for I in ones. Okay? And then max 0, equals max length I for I in 0. Right? So we're going through the elements in the array and we want to apply the length function and to find out the length and then similarly return max 1 bigger than max 0. Actually, the max function supports the key. So actually this one we can say max 1 equals the length of max let's say 1 key equal length. Okay? And then here similarly max 0 equals the length of the max 0's key equals length. So what's this key? Key parameter specified, we specified a length function to say, okay, if you want to get the maximum, let's use the key, which is the length function. Okay, so what does it mean? It means that find out the maximum element of the array, but how do you determine if it's the element is the maximum? By its length. So you give me this 1, 1. Okay, so if give me 1, 1 and I get the length.
This is determined.
Determined, okay?
It's not determined.
Yeah, determined, okay. Make sense?
Determined. There's a difference.
Okay, let me give you an example. Okay,
That one.
I want to find out the maximum.
one.
This is S, okay, this is S, okay. Max S, but the key is the length. Okay, so which
You
is
found it
return?
all together.
Max
That one.
S key equal length. So which one? This one, right?
Yeah.
Yes, because I want to get the maximum. So what determines the maximum, the value?
Sum.
The length. The length. Okay, the length. Yeah, the sum, yes. In other words, the sum.
Yeah.
The bigger length is bigger sum, right? It's the same thing. Okay, so this is using the split. Another way, the third way is using the GroupBy. GroupBy. So GroupBy is actually quite straightforward. For example, like 1 1 1 0 0 0 1 1 1 1. Okay, so if we use the iter2 of GroupBy, what does it return? You return the iterator, emulator. Okay, so iterator will be okay. So this is a group, right? This is a group. This is a group. So you return 1, and the value will return the group of it. This is the iterator. 0, return 0 0 0. It points to this is the key. This is the key. This is the value. Okay, and then 1 1 points to its group, which is 1 1 1 1. Okay, so we use the iterator. We use the iter group. Then we can rewrite this. Define f as for I group in iter2 GroupBy s, right? GroupBy s if I equal 1. Okay, if I will be the unique element of each group, the G will be the iterator to the actual group. Then here that's the max 0 equals max 1 equals 0. Okay, so max 1 equals max 1 max 1, the length of the G is the iterator, we need to convert it to a list. Okay, as max 0 equals the max, we want to get the maximum, right? Max 0, the length of list G. Okay, and then return max 1 bigger than max 0. GroupBy, iterator GroupBy returns a tuple, a key value. Key is the unique element to the group. G is the actual group, and then because this is the iterator, when we want to get the length, we need to convert it to a list. And this is similar. We can simplify this implementation by using a counter. For example, here we can say, okay, C. Here we can say C equals counter, and then Ci, right? We put this I in the dictionary. Ci equals
It's a fish, right?
max Ci
Isn't it a fish?
length G. Okay, and then we can say C return C0. C1 is bigger than C0.
It smells
So,
like glass.
By using the counter, we don't.
Microscope.
Every line. By using the counter, we don't need to use we don't need to check the if. What have you learned today? That's it.
We have learned about
Come on, say it. 快点，快点。Please.
that we have binary numbers. One, and we want to find if the consecutive ones are greater than 0, and if it returns true, well tick. But if not, false. And my approach, I said, is to go. You get set like your brain memory and count the first digit starting, and if it ends, you remember and putting in the set, and then moving on to the next number, start counting that one, and then keep on repeating the process until you go to the end, and then you count.
There's no set. The set only stores unique numbers. You mean the counter, right?
Yeah, counter.
Okay.
Because it counts the counter.
Yeah. Okay. Ari?
Yeah.
How many ways we talk about today?
2.
3.
3. 1, 2, 3. Okay. So
1, 2.
can you explain to me one of it?
Okay.
One of them is my way. I already said.
Okay, mine's way is that you go through one.
Ryan's way. Which way is Ryan's way?
The
Okay, this one. Okay. So
Because it's the first one we done.
yeah. Okay. So can you explain to me this?
so you count the ones, and when you meet 0, you restart, and then you
Reset. Yeah.
start counting.
The zeros.
We start counting of 0. Yeah, but we increment the counter 1. Okay. Yes. Make sense?
No, that's what I'm saying. And I'm saying we start counting.
Okay.
Oh my God.
This one is the most efficient one because it is on time and O1 space. Okay, and this one is we're going through twice, right? We're going through twice, and then we need to keep tracking of the array here. So this is ON space as well. And this one GroupBy internally use the ON space. Okay. Okay, that's it for today. Bye bye. Bye bye. Bye bye.
Oh, yeah.